Hello class, today we're going to talk about Unit 3, our ratios and proportions unit. When we talk about ratios and proportions, we're talking about comparing parts of things to a whole thing. A lot of times we see these written as fractions, but you can also see them written as phrases with the word to in between. That to serves as this division bar, the fraction bar. So let's talk about our learning targets. What we're hoping to do is understand the relationship between fractions, multiplication, division, and whole numbers. We're going to use ratios and proportions to solve real-world math problems. And we are going to identify and apply ratios and proportions to similar polygons or shapes when solving problems. So let's get down to some vocab. The word ratio is a comparison. It's a comparison of one group to another group. See the word to? That's our division symbol, that fraction bar right there. So let's talk about some examples. We can compare the number of boys to the number of girls. We could compare the cost of gasoline at Super America to the cost of gasoline at Holiday. That would be Super America to Holiday. We can compare the number of iPhones to the number of phones of another brand. What are some other examples you can think of when you compare one thing to another? We talked about ratios. Let's talk about the vocabulary word proportion. A proportion shows part of something to ratios that are equal. So it would be like setting up this with an equal sign in between. So here we have one fraction compared to another fraction. In order to figure out if these ratios, 1/2 to the ratio 4/8, is equal or proportional, what we can do is we can cross multiply. We could multiply the top and the bottom, the top of one side, and the bottom of another side to see if they're equal. So here I could take 2 times 4, and 2 times 4 is 8. And then I could take 1 times 8, and 1 times 8 is 8. Since the cross multiplication of 2 times 4 is 8 and 1 times 8 is 8, I know that they're equal. Over here, I could do the same thing. I could take, let's see, 5, I could take 5 times 7. 5 times 7 is 35. And 1 times 7 is 35. So these are both proportional or equal. We're going to use cross multiplying a lot in this unit. Remember that a fraction is a division problem, but we're going to cross multiply the top and the bottom of opposite sides to see if they're equal. Again over here, 6 times x is, I mistyped this. 6 times x is 6x. 5 times 150, use your calculator. That's right, 5 times 150 is 750. So again, my first step was to cross multiply 6 and x to get 6x, and 5 and 150 to get 750. My second step that I'm going to use, I wrote it over here in the side, is to solve for x. Remember, we're going to solve for x by division. So if you look down here, I combine these two answers into an expression, 6x equals 750. To solve for x, I need to move the 6 to the other side. Right now, this says 6 times x, so I'm going to do the opposite. Yes, because I want to get x alone. So I'm going to divide 6 by both sides. 6 cancels here, and x is alone. Then I'm going to divide 750 by 6. And you see how I wrote it down here using that slash bar, the division bar. I'm going to put that into my calculator. And when I do, I get the answer of, are you using your calculator? Do it along with me. Yes, 125. So that means that if 5 is proportional to 6, then this number up here has to be 125. So we can use this to solve other problems. We can also use it for similar triangles. So with triangles, you know triangles have 3 sides. Oops. All the sides on a triangle are proportional to each other. Similar triangles have the same ratio or proportion. So what we're going to do and what we need you to do is to learn to start marking your triangles. So we're going to show that sides correspond or relate to each other from one triangle to another. So you see here I used one slash on this side in orange or yellow to compare it to its similar side over here. See where the right angle is? And see where the longest side is across from the right angle? So this up and down part, I put one slash because these two are corresponding. I put 2 red marks here and here because they're corresponding. Notice that orange and red come together at the right triangle, or the right angle. And then I use 3 to mark the longest side here across from the right angle. So I know that this is proportional to that. It doesn't mean they're the same length. It just means that on the triangle they're that much bigger when you look at the other triangle. So we're going to try and find these ratios. You're going to get used to marking triangles like this as well. So let's look at an example. The triangles below are similar. We have the yellow triangle and the green triangle. Remember, to find x, you have to do the opposite. So if I was going to find this side, I first have to, number 1, set it up as a fraction, and number 2, cross multiply. So where I have the 3 here, you see my 1 hashtag of orange, and the 9 is 1 hashtag of orange. So I'm going to write it, first triangle 3 over second triangle 9. I have a 2 here by the 4 and a 2 here by the x. So I'm going to write 4 over x. See, I have yellow triangles on top, green triangles on the bottom. Corresponding sides, these marked sides, are what go next to each other. So, since 3 is proportional to 9 and 4 is proportional to x, I write it as a fraction like this. 3 over 9. See, my left sides are over here, and my bottom sides are over here. 4 is to x. Yellows are on top, greens are on the bottom. Why do I keep saying that? Because this is where most people make a mistake in doing this. Remember, one triangle, 3 and 4, need to be on top on either side of the equal sign. When I do the work, I cross multiply 9 times 4, 9 times 4, I get 36. I cross multiply 3 and x and get 3x. So when I put that together into a sentence, I have 3x equals 36. This equals this. So I need to solve to find out what x is. I need to find this missing side. Well, this says 3 times x, so I'm going to do the opposite. Divide 3 by both sides. The 3's cancel, so x is alone. And then I have 36 divided by 3. 36 divided by 3 is 12. So this side right here is 12. You getting the hang of it? So when I look at this problem down here, I'm going to first label it with my symbols. I've got the longest side here. I marked with 1 this time. It doesn't matter how you mark it, just that the sides that are similar on each one have the same amount of markings. And that's x. So the longest side over here I marked as 10. They're both triangles, you can see, are facing the same way. So the top I marked with 2 bars, 50, and the top over here I marked with 2 bars, 5. And then I have my third side here that's on the left. So first thing I need to do is set up my proportion. I'm going to go with the first triangle over the second triangle, and then I'm going to cross multiply. So here I set up 50 over 5, first triangle, 50 over 5, second triangle. First triangle x over second triangle 10. I'm going to cross multiply. Remember 5 times x is 5x. 50 times 10 is 500. 5x means 5 times x, so I need to do the opposite of times. That's right, that's divide. Divide 5 on this side to get rid of it, and x is alone. And 50 divided by 5 is 100. That means that this side is 100 inches long. This side's 10. This side's 100. Let's look at that a different way. 5 times 10 is 50. What's 100 times 10? 5 times 10 is 50. What's 10 times 10? Yeah, it's 100. This triangle is 10 times bigger than this one. That's a scale factor.